అదే करो, लाइट्स ऑफ करो ना पूरा। మధ్యలో నాకు అది బుక్ అవసరం ఉంటుంది సార్, అది ఇక్కడ పెట్టాడు తీసేసుకుంటాం, అది ఇందులో పెట్టి ఇక్కడ పెట్టేస్తాను సరిపోతుంది. Start. Okay. Good morning, students. Today we'll discuss one important long answer question from intermediate first year. This is the second question for upcoming supplementary examination. 3-star question. Define work, kinetic energy, work energy theorem. So this is the second LAQ from mechanics zone. Yesterday I gave clear explanation about law of conservation of energy, freely falling body. Law of conservation of energy, freely falling body with problem. This is the second question. Define work, kinetic energy, work energy theorem. This is the 3-star question. These 2 questions chance for upcoming examination. 19th bit question number 19 LAQ you are getting from mechanics zone. So you are reading 2 questions from the 2 compulsory one. Last IP annual examination, collision. In annual examination they gave collision concept. So except collision, remaining 2 LAQs important. The 2 yesterday one concept, law of conservation of energy. Now today topic, work, kinetic energy, work energy theorem. First of all, we will discuss what is the meaning of work. Work denoted with capital W. From lower class onwards, you are reading this work concept, kinetic energy, potential energy, power, momentum, all this one routine concept from lower class. So they're asking question, define work, kinetic energy, work energy theorem. First, work denoted with capital W. W equals to F dot S. F stands for force. S stands for displacement. Dot product of force and displacement we are calling work. Work denoted with capital W. So work equals to F dot S. F nothing but force, S nothing but displacement, dot product of force and displacement. So dot product, this unit joules, work SI unit joules, otherwise CJS units, or work always equals to dot product of force and displacement. Work is a scalar quantity. For work, magnitude present. There is no specified direction. That's why work is the scalar quantity. Work equals to dot product of force and displacement. They're asking define work. Next, kinetic energy. So one more side heading. Kinetic energy. Kinetic energy Ke equals to half mv square, half mu square. Anything, no problem. Kinetic energy means energy possessed, energy received, energy gained by a body due to its motion. One body under motion, which energy present? Kinetic energy present. So energy related to body motion. The definition we are writing, energy possessed by a body due to its motion. Kinetic energy means half mv square. V stands for velocity. V stands for final velocity. Anything, no problem. So remember, they are writing half mu square also. So that formula also no problem. One is work dot product of force and displacement. Second one, kinetic energy. Kinetic energy means half mv square. Unit, again, joules or erg. This one also scalar quantity. Define work, work statement over. Define kinetic energy over. Next, work energy theorem. So student, work energy theorem, before that one, again I am repeating, work denoted with capital W, F dot S, dot nothing but scalar product, dot nothing but dot cos theta. So W equals to F dot S, dot product of force and displacement. One more statement, definition of kinetic energy. Kinetic energy means energy possessed, energy received, a body with respect to its motion. Ke equals to half mv square. Work over, kinetic energy over. Next, our topic, long answer continuation, work energy theorem. Work energy theorem statement. Work energy theorem. So work equals to work done by a force. Work done by a force. Work always equals to change its kinetic energy. Delta Ke indicates kinetic energy final minus kinetic energy initial. Kinetic energy final means half mv square. Kinetic energy initial means half mu square. Overall, we are writing capital W equals to half mv square minus half mu square. Work always equals to change its kinetic energy. This is the statement of work energy theorem. Now I want proof work done always equals to, work done by a force always equals to change its kinetic energy, half mv square minus half mu square. For this one, proof. Now I am giving proof, explanation of proof. Work equals to half mv square minus half mu square. I am giving some diagrammatical explanation. Just consider one body mass m. M is the mass of the body. Initially, it is moving with u velocity. U stands for initial velocity. One body mass m moving on the surface. So just we are applying one force, capital F. F is the force applied on the body. M is the mass of the body. Its velocity changes from u to v. V nothing but initial velocity, u nothing but, v nothing but final velocity, u nothing but initial velocity. M is the mass of the body. What is the displacement means? Yes. So initially u is the initial velocity. When we are applying force, velocity becomes v. So u initial, v final, s is the displacement, external force, capital F. We know very well about v square minus u square equals to 2s. This is the equation of motion. V square minus u square equals to 2s. So I'm writing here v square minus u square equals to 2s. Both sides multiply with, okay, both sides multiply with m by 2. We are getting like this. Left side m by 2 and right side also m by 2. 2as into m by 2. Why we are multiplying means from this multiplication term we are getting one more step. Left side m by 2, right side m by 2. For example, m by 2 cancel means mathematically both are balancing equation coming. V square minus u square equals to 2s. Both side multiplication term we are taking m by 2 and m by 2. Left side we are getting m by 2 into v square plus into minus m by 2 into u square. What about right side? 2 cancel. Remaining step m a into s. We know very well famous formula, capital F. Force equals to ma. So F is equal to ma. Next step we can get like this. Half m v square, half m u square. See, half m v square minus half m u square equals to right side ma nothing but force into displacement. So force into displacement. What is the force into displacement? Nothing but work. So overall we are getting work equals to half m v square minus half m u square. This is our work energy theorem. Okay, students. Now one more rapid explanation I am giving. Today our topic, long answer question, define work kinetic energy theorem. In this one, see here, work denoted with capital W. Work denoted with capital W. Work equals to F dot S. Dot product of force and displacement we are calling work. Definition of work. Next one, kinetic energy. Work units joules and it is scalar quantity. Work over. Next, kinetic energy. Kinetic energy half m v square. Otherwise we write half m u square. No problem. Kinetic energy means energy gained, energy possessed, energy received by body due to its motion. Work and kinetic energy. Definition of work. Definition of kinetic energy. Individual, you can get mark. 1 mark for work, 1 mark for kinetic energy, 4 marks for work energy theorem proof, 2 marks for problem. Like that, individual scheme of evolution marks you are getting. Next, work energy theorem statement. Statement of work energy theorem. Statement, work done by a force. One work done by a force. Always work done equals to change its kinetic energy. Change coming means anywhere, not only here, anywhere. Change word coming means final value minus initial value. Delta indicates meaning final value minus initial value. Change anywhere, change coming means delta we are writing. So delta Ke. Delta Ke means final kinetic energy minus initial kinetic energy. Final kinetic energy means half mv square. Initial kinetic energy means half mu square. V stands for final velocity. U stands for initial velocity. Just proof one body with mass m initially moving with u velocity. External force, capital F is the external force applied on the body. When we are applying external force, its velocity changes from u to v. U is the initial velocity, v is the final velocity. So it travels some displacement s. Initially u velocity, finally v velocity, displacement s. F is the force, acceleration a. From this on all terms, we are taking from equation of motion v square minus u square equals to 2s. V square minus u square equals to 2s. Both side multiply with m by 2. Left side m by 2 coming, right side also m by 2 coming. Again m by 2 cancel means equation, we can get balanced equation. M by 2 into v square. This step we are writing half m v square minus half m u square. Left side half m v square, half m u square. This step over. Right side 2 gets cancelled. Remaining step m into a, ma, force word coming. Yes, ma nothing but force into displacement nothing but yes. So we are writing F nothing but ma. So instead of ma, F into s. Work always equals to Fs. So overall we are getting capital W equals to half mv square minus half mu square. This one we are writing like this. See. Work equals to change its kinetic energy. Final kinetic energy minus initial kinetic energy, hence proved. So this is the second long answer from intermediate first year. Every long answer including problem. Only 2 questions in intermediate first year without problem. One is collision concept. In annual examination, we are getting collision theory, collision concept without problem. And one more question, reversible process, irreversible process, Carnot engine. Except these 2 questions, remaining all questions including problem. Work, kinetic energy, work energy theorem over. For this one, we are having problems. Okay, students? Now say, this is Board of Intermediate textbook. So in this one, student, page number 141. 141. Lesson name, work, energy and power. From this one, problem number 4. Problem number 4, a pump is required. A pump is required to lift 600 kg of water. A pump is required to lift 600 kg of water. So mass of the water 600 kg. You know 600 kg nothing but 600 liter. 1 kilogram, 1 liter, approximately same. We are taking 1 kilogram, 1 liter. That's why they give mass in kilogram. Mass of the water 600 kg per minute. Time 1 minute. 1 minute means 60 seconds. They gave 2 values up to now. Mass of water 600 kg per minute from a well 25 meter deep, depth 25 meter deep, and to eject it with a speed of 50 meter per second. Water coming outside with 50 meter per second. Calculate the power required to perform the above task. Calculate the power required to perform the above task. What is the power? Power equals to question mark. Again, I am repeating. This question from Board of Intermediate, Telangana, Telugu Academy book students. Mass 600 kg. Mass of the water 600 kg and time 60 seconds. What is the depth of the motor? 25 meter. and ejected speed of water 50 meter per second. What is the power of motor? Power P, capital P, equals to rate of work, rate of doing work. Power equals to ratio between work done with time. Work per time equals to power. Here, for example, this is the well, one motor. How much? 25 meter deep. With respect to depth, with respect to configuration, work equals to potential energy. Motor under rest position, with respect to configuration, with respect to state of rest, work nothing but potential energy present, and motor, from motor, water coming outside with 50 meter per second, like this. With respect to motion, kinetic energy there. So work equals to here sum of kinetic energy plus potential energy divided by time. What is the potential energy formula? mgh, h value they give, plus kinetic energy formula half mv square divided by t. M 600 kg, G 10, approximately 10 in annual examination, 100% they are giving G value 10, and H equals to 25. Actual G value 9.8 meter per second square. And what is the velocity of water? 50 meter per second. From this data, we are calculating what is the power of motor. P equals to mgh, m 600, G 10, depth 25 plus half m 600 into v square 50 whole square divided by time 60. mgh plus half m v square divided by 60. So we are writing here mgh 600 into 10 into 25. mgh half m v square. V square means 50 whole square. 50 whole square means 2500 divided by time 60. Students, better for simple calculation, take 600 common. (25 into 10) 250. 600 common. So 1250, 600 common divided by 60. Tens are 250 plus 1250, 1500. 1500 into 10, 15,000 watts. This one we are writing 15 kilowatts. So what is the power of motor means 15 kilowatts. Again I am giving explanation. What they are asking means, for this work kinetic energy theorem, mass of water 600 kg. One motor at 25 meter deep with in 1 minute, it is lifting 600 kg water with how much speed? 50 meter per second. For this total performance, how much power required? Power equals to work per time. Work nothing but kinetic energy because of this motion. Work nothing but potential energy with respect to this depth. Potential energy mgh plus kinetic energy half mv square, time t. So substitute values. Mass 600, G value they are not giving. G value take 9.8, we can get one value. G value take 10, you can get one value. So 10 is the approximately value, student. mgh half m v square Take calculation part, 15,000 watts coming. You know, in our old Telugu academic book, what the value they gave means 12.5 kilowatts. That is the wrong answer. Answer 15,000 watts. Sometimes I observe number of times students, they are doing two mistakes after the calculation. What they are writing means 15,000 kilowatts they are writing sometimes. 15,000 kilowatts means that is the wrong answer. Our answer 15,000 watts. Don't write kilo. Sometimes they are writing like this. 15 watts. Again, this is the wrong answer. 15,000 watts, nothing but 15 kilowatts. Kilo, nothing but 1,000. Kilogram, 1,000 gram. Kilometer, 1,000 meter. Kilo indicates 1,000. That's why 15 kilowatts. Otherwise, go 15,000 watts. Don't mix two answers. You go 15 kilowatts. Otherwise, 15,000 watts. This is the problem for work kinetic energy, work energy theorem. Students, yesterday I gave law of conservation of energy, freely falling body. For that one problem. We'll do problem yesterday due to time problem we didn't do. So, work kinetic energy, work energy theorem. Definition of work, definition of kinetic energy with statement of work energy theorem. Fixed problem, this one, power of motor. Okay. Now, one more problem we are doing. This problem belongs to law of conservation of energy, freely falling body. Law of conservation of energy, freely falling body. A point, B point, C point. Every place we are getting MGH, MGH, MGH. Yesterday I gave this question explanation. For this one machine gun bullet problem. So now we will do problem related to law of conservation of energy. Same page number 141. Problem number 2. Problem number 2, a machine gun fires. This problem belongs to law of conservation of energy, freely falling body. Say problem number 2. A machine gun fires 360 bullets. Number of bullets 360. So you write given data. Given data, a gun firing 360 bullets per minute. Again 1 minute. Per minute, nothing but 60 seconds. And each bullet travels with a velocity of 600 meter per second. 600 meter per second is the velocity of each bullet. If the mass of each bullet is 5 grams, mass of each bullet 5 grams, find the power of machine gun. Again, they're asking power. Power equals to rate of work. Rate of doing work, we are treating as power. Work time is there, M is there, number of bullets, velocity. Machine gun firing, meaning bullets under motion. When a body under motion means it consists of kinetic energy. Work, equivalent energy, kinetic energy. This is the kinetic energy of single bullet. How many bullets there? 360 bullets. That's why we are writing some n bullets. Half mv square is the kinetic energy of each bullet. Total how many bullets present? N bullets. Half mv square into n divided by time t. Why we are not writing mgh? If you remember, they are getting doubt. Why we are not writing mgh? Because previous problem we wrote mgh. Here machine gun fires 600 meter per second. Any depth term not there, anything not there. That's why work convert into only kinetic energy. Now P equals to N, number of bullets, 360 into half mass of bullet 5 gram, compulsory conversion important student, 1 gram equals to 10 to the power of minus 3 kg. How we are getting means here. 1 kilogram equals to 1000 gram. Just now I said in previous problem, kilo indicates 1000. 1 kilogram nothing but 1000 gram. Here 1 kilogram nothing but 1000. I am writing like this, 10 to the power of 3. Then 1 gram plus 3 there. Left side we are taking means 10 to the power of minus 3. Plus means minus. 1 gram equals to 10 to the power of minus 3. This one we are writing 1 by 1000. So all terms SI except mass. SI unit, all terms SI unit. Our answer also in SI units we are getting 5 gram. Gram indicates CGS units. That's why we wrote 10 to the power of minus 3. When we are writing 10 to the power of minus 3, automatically this value belongs to SI unit. Number of bullets 360. Half mass 5 into 10 to the power of minus 3. Half m v square velocity 600 into 600 divided by time 1 minute 60. Here 1 2 3 3 zeros minus 3 cancel each other. 60 cancel each other. Remaining term P equals to 360 into 1 by 2 into 5 into 6. $360, 15 jobs. So 5,400 watts. What is the machine gun power means? 5,400 watts. We are writing in kilo also. 5.4 kilowatts. You go kilo without kilo, not an issue. P equals to 5,400 watts. This is the power of machine gun. This problem belongs to law of conservation of energy, freely falling body. So student, one more time I am giving this one. Up to now 2 LAQs over. After this I will give some brief explanation how you are getting long answer from this all 2 plus more 4 questions. Overall, law of conservation of energy, from problem they are giving different values. Given data, number of bullets 360. One machine gun firing 360 bullets in how many? Per minute. 1 minute equals to 60 seconds. Each and every bullet moving with 600 meters per second. Mass of bullet 5 gram. We are converting towards SI unit. What is the power of machine gun? Power P equals to work done per time. Work half mv square, because work convert into kinetic energy. Number of bullets, because here they gave 360 bullets, that's why I wrote n divided by t. Substitute values on calculation we are doing means what we are getting 5,400 watts. Up to now 2 LAQs over students. Annual examination, how many LAQs you are getting? Special concentrate on upcoming point. Say LAQs in annual examination 19, 20, 21. Question number 19, 20, 21. We are getting long answers. 19th question from mechanics. Work, power, energy lesson. For 19th purpose, From these two, you are getting one. 19th first question. Law of conservation of energy with bullet problem. Just now we did 5,400 watts. Question number 1, all 3-star questions. Law of conservation of energy with bullet problem. Second question, define work kinetic energy. Work energy theorem with 2 problems, students. Just we did 1 problem only, 1 more problem balance. Define work kinetic energy, work energy theorem. 1 problem, power of motor 15 kilowatts. 1 more, there was also power of motor 170 horsepower. 1 problem, power of motor in watts. 1 problem, power of motor in horsepower. Second problem balance. After this topic, I will give explanation. From these two, any 1 problem you are getting for define work kinetic energy, work energy theorem. So 2 questions for 19th. For 20th bit purpose, question number 1. Define SHM. Question number 20 from oscillations. Oscillation 8 Morse weightage. Work power energy 8 Morse weightage. 1 more thermodynamics 8 Morse weightage. So define SHM. So that particle motion SHM, a particle moving in circular path. With respect to diameter, its motion is SHM. So define SHM. A particle moving in circular path so that its motion is SHM with respect to its diameter. I wrote shortcut, student. Question number 1, define SHM. Question number 2, previous annual examination, we got this question. Time period of simple pendulum. Time period of simple pendulum with ticks of pendulum. All this one special cases. Question number 19, 2 questions. Question number 20, 2 questions. Up to now, I gave these 2 questions explanation except this problem. From these 2, 1 coming. From these 2, 1 coming. Actually, you need 2 only. 1 more safe side, you are reading 21 bit. Everyone focus on board. Law of conservation of energy, freely falling body with bullet problem. 1 question. Define work kinetic energy, work energy theorem. From this 2 problem, 1 coming. Long answer question. Define SHM, particle motion, a particle moving in circular path with respect to its diameter, its motion is SHM. Expression for time period in the case of simple pendulum. So 2 questions, 1 coming. From these 2, 1 coming. Question number 19th and question number 20. Now 21. See. Newton law of cooling. With surrounding temperature 28.3 degrees Celsius. reversible, irreversible process, Carnot engine. Question number 21, Newton law of cooling, surrounding temperature problem, and one more reversible process, irreversible process, reversible process, and one more is the irreversible process, Carnot engine. Out of 6 here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. From these 6 questions, minimum you are getting 2 questions. Actually 3, but we are going minimum zone. 2 questions required in examination. From these 6, we are getting 2 questions, student. Total 6. Up to now, this question over, this question over. Now I am giving this problem explanation. Tomorrow, define SHM. Next time period. Last, Newton law of cooling, reversible process, irreversible process, Carnot engine. Amen. क्या हुआ? One minute. Wait, student, 1 minute. Okay. Here, total 6. 1, 2, 3, 4. 2 questions from work, power, energy. 2 questions from oscillation. Remaining 2 from thermodynamics. Some thermal properties of matter. So every student focus on this problem. I gave already this question, this problem explanation. Define work, kinetic energy. 1 minute. Say right here. Mobile open this, sudo mobile open this. Okay. Now, see our students, problem number 2. Stop. तो बोलो तो 11 o'clock और एक क्लास अब तक एडजस्ट करो आप, समझ में है ना भाई? मेरा दूसरा टॉपिक कल बोलते, कुछ भी नहीं प्रॉब्लम. ऐसा क्या होगा बीच में? ऑटोमेटिकली रोटेट, ऐसा क्या? हाँ रोटेट हो गया, रोटेटेड क्या? कुछ मैग्नेट है ना, तो कैसा?